Welcome back everyone. In this video, we can discuss about the simplification of canonical forms using Kmap. In short, we can call it as Kmap. We have already learned the simplification of Boolean expression canonical form using Boolean laws and theorems, right? But this simplification using this Boolean theorems and laws are actually time-consuming process. So we can introduce here the Kmap simplification method, which is very easy. So this Kmap is actually a graphical method which consists of 2 raised to n cells for n variable function. If the given function is of n variables, then we need a Kmap with 2 raised to n cells. This Kmap method is most suitable for minimizing Boolean functions of 2 variables or 3 variables or 4 variables and 5 variables. So in this Kmap, the basic requirement is grouping of variables. We can make different groups of variables, or we can make different groups of Kmap cells based on the power of 2. We can make a group with cells 2 raised to 0. That means a single cell group 2 raised to 1 means 2. That is a group of 2 cells. And 2 square is 4. So we can make a group of 4 cells. Here it is 8. So we can make a group of 8 cells. And 2 raised to 4 means group of 16 cells. Like that. We can make different groups of cells as a power of 2 in the Kmap. So consider a 2 variable Kmap. 2 variable Kmap means the given function is of 2 variable, right? So in that case, how many cells we needed in our Kmap? Here it is 2 variable. So 2 variable means then our Kmap required 2 to the power 2, that is 4 cells. So the Kmap representation is, or the Kmap structure is like this for a 2 variable function. Okay, so here we can consider this function f with 2 variables, and the variables are like x and y. We can represent the Kmap like this. This Kmap is of 4 cells, 2 rows and 2 columns. And we can represent this variable like this. In this corner, we can mark x here and y here. Okay. Then this first row is marked with x value equal to 0. Here it is marked with x value equal to 1. And this y actually indicate 2 different columns. The second variable y indicate 2 different columns, and here y equal to 0. This column indicate the column with y value equal to 0. This one is column with y value equal to 1. So these cells corresponding to the values, here x equal to 0, y equal to 0. Here x equal to 0, y equal to 1. And in the cell, the value corresponding to x equal to 1 with y equal to 0. And this one, x equal to 1 with y equal to 1. Okay, so next is about the grouping. Here we can generate different groups, and the group must contain cells as a power of 2. Power of 2 means we can consider, here it is a group with 2 cells. 2 cells means 2 to the power 1. So we can consider a group like this or this. Okay, and also we can consider we can consider group like this. That is, vertical group contains 2 cells. And next is a group that contains 4 these cells together in a single group. Okay, and also we can consider a group with single cell. right? Single cell actually means 2 to the power 0. Okay, so these different groups are possible in this 2 by 2 Kmap or 2 variable Kmap. Okay, so consider one function which is represented here in this form of truth table. Two variable a and b, and its different input combinations are like 0, 0, 0, 1, 1, 0, 1, 1. And the output function values, output function represented using f, and these values are listed here. For 0, 0, output is 1, 0, 1, output is 1, 1, 0, output is 0, 1, 1, output is 1. Okay, now we can simplify this using this Kmap map. Okay, first we can consider this Kmap simplification for SOP form. Okay, SOP form, we need to consider this the same 2 by 2 Kmap with variables, input variables a and b. A is represented here, b is represented here for representing two columns. And next, the values of b. The first column with value 0 and second is indicated by the value of b as 1. And here, a value is represented as 0. The second row, a value is 1. Right? Next is, we need to mark the values here. So, remember this, we are going to simplify the SOP form. Sum of product terms of this given function. For the sum of product terms, we have already discussed about this. For the sum of product terms, we need the input combination whose output value equal to 1. These three input combination having the output value 1 here. Okay, the first combination is A is 0 with B is 0. That is A with 0. This row with this column. Here we want to mark the value 1. Next, here, that is A with 0, B with 1. A with 0 means this particular row, and here B with 1 means this column. So here we want to mark the next one. And here it is 0. For the SOP form, we need this input combination whose output equal to 1. So we need to consider this particular row next. Right? So here A equal to 1, B equal to 1. That is this row and this column. So this particular cell. Here we want to mark the next one. Right? And this one actually indicate this value. That is A equal to 1 with B equal to 0. We put value 0 here. And in the SOP form, we need to consider group of ones. That means in these cells, after marking these zeros and ones here in this cell, we need to make different groups. And always remember, try to make group of maximum possible size. Okay, here we can't make a group of 4 cells. Why? Because in this particular cell, we have the value 0. Okay, so the maximum possibility is group with value 2 ones. Okay, so what are the groups possible here? We can consider a group like this and this. We can't make here a full group with 4 cells. Why? Because here we have one cell with value 0. In the case of SOP form, we need cells with value 1s. Right? So consider these two groups. These two groups only. Okay, so here, what is the minimized or the min term representation corresponding to this group? Here, for these two ones present inside this group, the A value is 0. This particular row is common to these two ones. So the A value is 0 here. Right? So remember the point, for the SOP form, if the variable value equal to 0, then in the min term we need to represent its complemented form. Right? So if the variable with value equal to 1, then in the min term we need to mark its original form. Okay, based on that, so consider these two ones present in this group. Right? So here this particular A is common for this and this. This one actually indicate 0, A with 0, B with 0. And here A with 0, B with 1. So the A part is common. A with same value and the 0. So we can represent it here this A in its complemented form. Next, check column wise. That is, consider this particular group. Here B with 0 for this particular one, B with 1 for this particular one. That means this B is not common for this group. So for this particular group, the horizontal group, the minimized min-term representation is a complement only. So here we are considering the SOP form representation. So in SOP form, we need to combine different min-terms using our OR operation, logical OR operation. That is why this plus operator here. So consider next this particular group. Okay. So for this particular group, this particular vertical group, which one is common? This A is different. For this one, A is 0. This particular one, A is 1. So A is different for this particular group, this group. But B is common to this and B is with value 1. In SOP form, a variable with value 1, then we need to represent its original form. Okay, so this is the Kmap simplified representation corresponding to the SOP form of this particular given function. Right? Next, we can consider the POS form representation corresponding to the same given function. So for the POS form, we need to concentrate over this output value equal to 0. That means we need to consider the input combinations whose output equal to 0. So here we have only one cell with value 0. So the maximum possible group is this single cell only. Right? So the values are exactly like this. Okay. First row with value 0, second row with value 1, first column with value 0, second column with value 1. And here for the POS form representation, we are interested in this output value with 0. Which input combination is having this output value 0 for A equal to 1 and B equal to 0. So here A equal to 1 and B equal to 0. Here we put the value 0. So the maximum possible sized group is this one, the single cell only. So what is the combination or what is the representation? So here for the POS form, remember the point. For this cell, the A value is 1 and for the column value, that is the B value is 0. A with 1 and B is 0. Right. So in the POS form representation, if the variable is with value 1, then in the POS form representation, in that max term, we need to write its complemented form, the variable's complemented form. And in the max term, if the variable with value 0, then we need to represent its original form. So based on that, here we can represent expression for this particular 0 like A complement plus B. Here A with value 1, that is why this A complement. Here B with value 0, that is why this B. And this is the POS form representation. So the max term contains the logical OR operator. Okay, if there exist more such groups, then these terms are combined using AND operation, logical AND operation, like this. Okay, so these are about the SOP and POS simplification using a two-variable Kmap. Next, we can consider the three-variable Kmap. So its basic or the general syntax of a three-variable Kmap is like this. Using three variable, how many values are possible? 2 raised to 3 equal to 8. So here it is a Kmap with 8 cells. The representation is like this. 2 rows. Each row contains 4 cells. Okay, now we can mark the variables like this. Suppose the given function f of f with three variables like a comma b comma c, then we can represent like this. Here we have two rows, so a single variable is marked here. The first variable is marked here along this row, and for the column here we have four columns. So the remaining two variables are used for representing different column values. So the possibilities of these rows are like 0 and 1. Possibilities for the columns are 0, 0, 0, 1, 1, 1 and 1, 0. So this is the, this one is an important point we need to remember always. 0, 0, 0, 1, 1, 0 and 1, 1. We need to follow this particular order of our column. 0, 0, 0, 1, 1, 0, 1, 1. Not 1, 0 here and 1, 1 here. Okay. So, we don't want this particular order. This is the right order. 0, 0, 0, 1, 1, 0, 1, 1. So, different cells indicates values like 0, 0, 0. A with 0, B and C with 0. Next, this is decimal 0, this is decimal 1, this is decimal 2, this is decimal 3. Next, decimal 4, decimal 5, this is decimal 6 and this is decimal 7. Okay, so this is the general syntax of a three-variable Kmap. Now consider some different possibilities of grouping like this. We can consider single group like single cells. That means 2 raised to 0 cells. Another possibility is group with 2 cells like this. Okay. And we can also consider vertical groups like this, and also consider horizontal groups with 2 cells like this, and this. Okay, another possibility is group with 4 cells. That is, these 4 cells together, like this. Also, these 4 together, these 4 together. Okay. So another possibility is group like these two leftmost cells with these two rightmost cells. Okay. So consider one example. This is a SOP form which is given. We need to simplify using this three variable Kmap. Here the function is with three variables and the values are ranging from 1 to 7 here. 1 to 7 means these values we can represent it using three values, 3 bits in binary. So for this simplification we need a Kmap with 3 variable maximum. Okay, so consider the Kmap representation. with this row part included A and the column is indicated by B and C. The values are like this. Okay, now this one is actually 0, this is decimal 1, this is decimal 2, this is decimal 3, and this is 4, this one is 5, this one is decimal equivalent of this binary is 6, and this is 7. So based on that, 1 is represented by this particular cell. So mark 1 here. Because here we are dealing with the SOP form. So we need the input combination whose output value equal to 1. So mark 1 here. And here it is given 3 next. 3 is represented by the cell this. So mark 1 here. Next is 6. 6 is marked by this particular cell. And 7 is represented by this particular cell. So mark F1 here. So these are the cells with value 1. So remaining cells is indicated with value 0. This is by default. So this is the soft form representation given. From this it is clear that for these 4 input combinations we have the value 1, and for all other combination we have value 0. That is why we put 0 here. Okay, now we need to make different group. Here we can make group with maximum size equal to 2. So the possible groups are like this. Okay, so this is the right grouping. Here we have one more group like this. But is this group is necessary here? This one is actually, this particular green group is actually a redundant one. Why? Because considering this particular group, then we need an extra group. This is essential group here. This is essential because we need to include this particular one in some group using this particular blue group. So while considering this, we need extra group this in order to make this one inside a group. Similarly, while considering this particular group, we need an extra group here in order to make this one inside a particular group. Okay, so the best grouping is this blue and this blue. So while considering these two group, this green group become a redundant. We don't want that particular group here. Without that group, we have already grouped the ones present in this cell using this blue group and blue group. So consider these two blue groups. Okay, this is enough for this particular simplification. Consider this, and for this grouping, what are the simplified min terms? Here it is SOP form, so we need to consider the min term. Okay, so for this A value is common for these two ones present in this group. And column wise, which one is common? The C value. Right. So the minimized representation for this one is SOP form. In SOP form, if a variable with value is 0 present, then in the min term we need to use the complemented form. And if a variable with 1 is present, then we need to use its original form. Here A with value 0, so mark A complement. And here this group is actually indicated by A complement and C. Here C with value 1, which is common here and here. The C with value 1. So use original form of C. And these two variables are combined here using logical AND and generate the min term. Next, consider the next group. Here A with value 1 is common. And here, which one is common along this column? B with value 1 is common. C values are different for these two ones. Right? But B is common. So the representation is A and B. A with value 1, so its original form is required. B with value 1, so its original form is required. So these two main terms are combined using logical OR operation. So this is the this is the minimized SOP form using Kmap simplification here. Okay, next consider a three variable Kmap simplification for the given product of sum terms. So the product of sum term is given here like 0, 2, 6, 7 with three variables. Here the maximum listed values are ranging from 0 to maximum up to 7. So for 7, for the representation of 7 in binary, we need maximum of 3 bits. We need minimum 3 bit. Okay, so that 3 bit is enough for representing all the values listed here. So we need 3 variable Kmap. So the representation is exactly like this. Along the row, we mark a single variable A, and for the representation of column, we use two variable B and C here. And for A, the values are 0 and 1, and for this 0, 0, 0, 1, and this one is 1, 0, this one is 1, 1. So remember this order 0, 0, 0, 1, 1, 0, 1, 1. So in the POS form representation, we need to concentrate over value 0. So for this 0, we put 0 here, and for the cell indicating 2, which one is 2? 0, 1, 0 is 2. So this in this particular cell we need to mark 0. Next is 6. What is the binary of 6? 1, 1, 0. 1, 1, 0. So this particular cell. Here we put a value 6, 0. And again 7. 7 means 1, 1, 1. 1, 1, 1. So here again we put value 0. And all other cells with value 1. Okay, so here we are considering the POS form representation. So in POS form, we are interested in cell with value zeros. Okay, so now try to make maximum possible sized groups. Here maximum possible groups with values 2, or we can make a maximum of 2 cells group with 2 cells maximum. So what are they? This one is one group, and this particular two combined together to form another group with two values. Here we can consider one more group like this. But this one is a redundant group. This is not an essential group. Why? While considering this group, we need an extra group, this one, in order to combine this 0 inside a group. So while considering this particular vertical green group, we need one more group in order to include this particular 0 inside a group. So this particular vertical green group is actually redundant here. That is not needed here. These two groups are essential groups. Okay, so considering the essential groups, okay, consider these essential groups and try to generate the minimized POS form. So in the POS form, remember the point, if the variable with value 1 is present, we need to mark the complemented form of it. If the variable with value 0 is present, then use the original form of the variable. So consider one group. The simplified POS form representation is like this. So consider this group. For these two zeros or this particular group, which value is common? This particular row is common. That means A with value 0 is common. So A with value 0 means represent the original form of A, that is A. And column wise, which one is common? The C value. C with value 0 is common for these two zeros. Okay. C with value 0 means we need the original form of C, and this is the POS form. So combine these two terms using logical OR operation. So this is the first max term. Okay. Next group is this one. Here which variables are common for these two zeros present in the group? A with value 1 and B equal to 1. B equal to 1 here. So we need, if A with value 1 means we require the complemented form of A. B with value 1 means we used here the complemented form of B. And combine these two using logical OR operation and make or generate the next max term, A complement plus B complement. So these two max terms are combined using the logical AND operation in case of POS form. So this is the minimized form of this given POS form or canonical product of sum term using Kmap simplification. Okay. So next is about the 4-variable Kmap, and the general syntax of this 4-variable Kmap is like this. Horizontally 2 variables, vertically 2 variables A, B and C, D. And the possible values are 0, 0, 0, 1, 1, 0, 1, 1. Please note this order 0, 0, 0, 1, 1, 0, then 1, 1. 1, 1 is represented by the third row. 1, 0 is represented by the fourth row. Here also, first column 0, 0, 0, 1, 1, 0 represent the last column, 1, 1 represent the third column. Okay, so this one actually indicate value 0, decimal 0 equivalent, decimal 1 equivalent, decimal 2 equivalent, decimal 3 equivalent. This one is 4, this is 5, this is 6 and this is 7. And this is 8. Next 9. This is 10 and 11. And this one is 12, 13. This one is 14 and this is 15. So this is the general syntax of a 4-variable Kmap. And next is about grouping. We can consider single cell as a single group. And next is 2-variable group or 2 cells, group with 2 cells like this. And we can consider group these two together. We can form a group while combining 2 rows horizontally or vertically. All these are valid group. And also consider 2 group like this. Next is group with 4 variables. 4 cells together. We can consider these 4 cells to form another group, these 4 cells to another group, and so on. Okay, and 4 group like this. These 2 and these 2 form another group with 4 variables. Okay, here also we have 4 variable or 4 cell groups. Combining these with these, again this with these. Next, we can combine 4 cells. How? Combining the 4 corner cells together to form a group with 4 cells. Okay, this is also valid here. Combining 4 corner cells together to form a group with 4 cells. And also we can combine these 8 cells together to form one group, these 8 cells together to form one group, these 8 cells together to form another group. And vertically we can combine 8 cells together, these, this. And also all the 16 cells together we can form a single group. So now we can consider the simplification of a 4-variable Kmap for the simplification of SOP form, canonical SOP form. The listed canonical form is like this: 0, 2, 5, 7, 8, 10, 13 and 15. Here the listed values are ranging from 0 to 50. So for the representation we need a minimum of 4 bits. That is why 4-variable Kmap. Okay, so the representation is like this. So always remember this particular order: 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1. Now we need to mark these values. 0 present here. So this is a SOP form representation. That means for these input combination we have output value 1 here. So here we need to mark 1 for 2. This is 0, 0, 1, 0. This is 2. And 5. What is the binary of 5? 0, 1, 0, 1. 0, 1, 0, 1. So mark 1 here. Next is 7. 0, 1, 1, 1. So mark 1 here. Next is 8. 1 0 0 0. 1 0 0 0. Mark 1 here. Next is 10. 10 in binary is 1 0 1 0. Mark 1 here. 13. 13 in binary is 1 1 0 1. So put a 1 here. 15 in binary 1 1 1 1. 1 1 1 1. So put a 1 here. Now we can combine different, or we can make different groups while combining different cells. So here we have the all other remaining cells are left with value 0 by default. So these are present in the SOP form. So the all other cells contains value 0 by default. Okay. So this is the marked form of our for variable Kmap. Next we need to generate the groups. Always try to make group with maximum size. Okay. So the possible groups are, this one is possible with 4 cells. Another group combine 4 corner cells together to form another group with 4 cells. Right? So its minimized representation is for this particular group. Which one is common? A is 0 here and 1 here. So A is not common. But B with value 1 here and B with value 1 here. This B value is common and with value 1. So in the SOP form, a value we want to represent it in its original form if it is with value 1 here. And in column wise, which one is common? C with value 0, C with value 1. This is not common for these two columns. But D with value 1, D with value 1, which is common. So the first minimized form for this group is B and D. So this is the first min term corresponding to this group. Next group, which are the common variables. Here A with value 0, A with value 1, not common. But B with value 0, B with value 0, which is common. And vertically, C with value 0, here C with value 1, which is not common. But D with value 0, D with value 0, which is common. So the minimized form is B complement D complement. Here variable with value 0 is common. That in SOP form we need to represent the complemented form if the variable with value 0. So represented B dash D dash for this green group. So we need to combine these min terms using logical OR operation in SOP form. So this is the minimized form of this particular given SOP form simplification. Next is about the POS form simplification using for variable Kmap. The for variable Kmap representation and the question is given like this. The product of some form, canonical POS form is given with values 1, 3, 4, 5, 6, 7, 12, 13. 13 comes under the range 0 to 15. Okay, so for the representation, we need a minimum of 4 variables, 4 bits. Okay, that is why we needed here 4 variable Kmap and the representation is like this. Now, this is the post form representation, so we need to concentrate over the output value equal to 0. For 1, we need to mark 0. 1 means 0, 0, 1, 0, 0, 0, 1. Okay, so put here 0. Next to 3. 3 means 0, 0, 1, 1. So this is one canonical form representation. Sometimes the questions may be like this two table form. Okay. So this is the truth table representation. This one is the truth table representation of the given canonical POS form. Okay. So based on this, sometimes the question may be like this and sometimes like this. So here for this combination 0, 0, 1, 1, the next 0. Here it is POS form simplification. So concentrate here in this combination with output value equal to 0. Okay, 0, 0, 1, 1. Here we need to put a 0. Next, here 0, 1, 0, 0. 0, 1, 0, 0. Put 0 next. 0, 1, 0, 1. Here. Next, 0, 1, 1, 0. 0, 1, 1, 0. Next 0, 1, 1, 1. 0, 1, 1, 1 here. Next here 1, 1, 0, 0. 1, 1, 0, 0. Next 1, 1, 0, 1 here. Okay, and all other cells by default with value 1. Right? Now we can generate group with maximum cells. So consider one group like this. Okay, and another group like this, and another group like this. This is the best grouping. We can consider some other group also, like group with two values. Here, group with two values. Okay, why? Because we have already included this two in this particular horizontal group. But always remember to group or form group with maximum cells inside it. That is why we are considering group with 4 cells here. Okay, keep this point. Always try to make group with maximum cells. Okay, so here generated group with 4 cells in these 3 groups. Now we can generate the POS form or the max term corresponding to these groups. Okay, for the first group, here, this particular horizontal group, which one is common? A and B are common. A with value 0 and B with value 1 is common for all these 4 rows in this horizontal group. So in POS form, if the value is 0, we can use the original form. If the value is 1, we can use the complemented form and combine these two using logical OR operation like this. A plus B complement. The first max term corresponding to this group. Okay, next we can consider this group. Okay, here which one is common? A with value 0 is common for these two. And vertically which one is common? D with value 1 is common. Okay, so how can we mark that max form? Here A with value 0, D with value 1. So A plus D complement. A with value 0. So we need the actual form of A, original form of A. D with value 1. So we need the complemented form of D. So A plus D complement, second max term. Third, for this particular group, here B with value 1 is common. And here C with value 0 is common. C with value 0 is common. B with value 1 means we need B complement. C with value 0 is common means we need the original form of C. And combine these two using logical OR operator. So this is the next max term. And combine these max term using logical AND operation because here it is the POS form simplification. Okay, so this is the minimized canonical POS form for this given canonical POS form. And the simplification is based on 4 variable Kmap. Okay, so in our coming videos, we can discuss more such examples for the Kmap simplification, and separately we can discuss about the 5 variable Kmap simplification. Okay, thank you.